Hi darlings, if you have not yet subscribed to my YouTube channel, please do the right thing. So this is the second segment of our test 2 set D. If you haven't watched the first video, please make sure to go watch it because it was talking about the time series part of test 2. This video is going to be focusing on the probability segment, which is question 7 all the way to question 10. So let us get right into it. So here's the question. Question 7 says, Table 2 gives a contingency table of brand performance for digital cameras and their primary usage, personal or professional. So usage, brand preference, right? So it says events A union B. What does A union B? It means the probability of A, right? So it would be the probability of A plus the probability of B less their intersection, right? But there's no intersection between them. Okay, let's look at the other one. It says C, right? It's talking about C, which is this full thing, and they are talking about D, right? So do you see that there's an intersection between C and D? So they cannot be partitioning, because for partitioning they need to be mutually exclusive and they also need to be exhaustive. So whenever you get a question about partitioning, just look at the options that you have. Start with the ones that do not have the union, because it's a bit hard to draw the union from a contingency table. However, it is much easier to draw the C and the D because you can see it's C, D, and if it is touching, then it's not partitioning. I made a video on partitioning, so if you don't understand still, then if you don't understand what partitioning is, please watch that video. It's the video where I was talking about tips you need to know before writing your test 2, right? Okay, so this is false. And then this is saying events D union A complement. Morgan's rule says that this thing is equal to not D, you swap the sign, and not A. I made a video on this as well, please check it out. So we're looking at the intersection of D, right? If it's saying not A, it means that it's everything else that is not A, right? So it's talking about not D and not A. So it's gonna be this whole thing right here, and it's talking about D, right? Okay, and it's talking about C. Here is C. So that is false because it is intersecting here, right? Okay. So this is false as well. The probability that a user prefers a Canon brand and utilizes it for personal usage is, so Canon is A, right? The probability of A intersection personal usage, which is not D. So the probability of A and not D is 20 over 220. So 20 divided by 220 gives us 0.90. So this is false as well. The next event says events B and C, or C, right? We'll come back to this one. Let's look at D. They are saying event D, which is this one, and not D. They are mutually exclusive, but we're looking at B union C. So in this case, it's not able to tell. We are not able to tell because you also need to test the O. Okay, in terms of the O, what does O mean? It means the probability of B, right? So it would be the probability of B. I'm going to erase just now. Probability of B plus the probability of C less the probability of B and C, but there's no union between B and C. However, if you check, this B is touching these two lines, so they cannot be mutually exclusive, so it is false. The last one says the probability of randomly selecting a user who prefers B, which is Nikon, right? Prefers B, or, meaning union, utilizes his or her camera for professional use, meaning D. So we're looking for the probability of B union D, right? So use the addition rule. What does the addition rule say? Excuse me, it says the probability of B, which is 90 over 220, plus the probability of D, which is 60 over 220 less the probability of B and D. So it's going to be 5 over 220. And it gives you 0.659. So this is the true statement. So this will be A, B, C, D, E. So E is correct for number 7. Right? Okay, let's go on to the next question. This is the 8th question. 2 more questions to go. It says let A and B be 2 events in the sample space such that the probability of A is equal to 0.65. The probability of B is equal to 0.78, right? So let's write that down. So this is a maximum minimum question. So it says the probability of A is equal to 0.65. So the probability of not A is going to be equal to 1 minus the probability of A, which is 0.65. This gives me 0.35. The probability of B is equal to 0.78. Hence, the probability of not B gives me 1 minus 0.78. Gives me 0.22. They tell me that then the minimum and maximum values of the probability of not A and B, right? This is what we are trying to figure out. So the first thing that I want you to do when you get a maximum or minimum question, okay, for those of you who don't understand what maximum and minimum is, it is that we have partial information. So we're trying to make a prediction of where this intersection is going to lie by making a range, right? So I'm going to show you how to do that in this video, in this question, right? So the first thing that I want you to do, step number 1, is to identify the sign. So this is the sign that is given, intersection, right? Okay, because there are rules that apply to intersection and they are different from the rules that apply to union. So now that you've seen that it's intersection, the second step applies to both union and intersection, and it is to add the 2 probabilities at hand. So what I want you to do is to highlight the probabilities that you are working with so that you don't get confused. So I'm looking for the probability of A, which is this value over here. I'm looking for the probability of A. I'm looking for the probability of B. So those are the 2 events I'm looking at. The other ones, don't get confused by them. So the probability of not A is going to be equal to 0.35. The probability of B is going to be equal to 0.78. And the sum of the 2 events is going to be equal to 0.35 plus 0.78. It's going to be equal to 1.13. So I want you to write 3 things: mutually exclusive, partial overlap, and full overlap. And if your answer is between 0 and 1, right, you will tick mutually exclusive, put a cross on this, yes, put a not, right, and then put a tick on the other one. If your answer is greater than 1, you'll put a cross on the mutually exclusive, a tick here, and a tick here, right? Okay, so since they are talking about the intersection section will be 1.13 minus 1, which will be 0.13, right? For the full overlap, since it's an intersection, it's going to be the smallest probability between the 2 events. So the smallest probability between 0.78 and 0.35 is 0.35. So the intersection will be 0.35. So meaning that your range will be as following. Approximately be the probability of not A and B is going to be between 0.13 and 0.35. And that corresponds to B, right? So that is B. So that's how you do a maximum and minimum question. If you do not understand, I also, on the video where I said tips to know when you are, tips to know before you write test 2, I go in depth about the maximum and minimum value, And I also go in depth about the difference between partitioning and overlapping. So that's going to help you with the previous question where we had to draw and see if they are partitioning. So please go watch that video, those videos, if you do not understand. Okay, let's move on to question 9, right? So I already did question 9 beforehand to make sure that we are efficient. So the question says, for any two events A and B, suppose that the probability of A is equal to 0.7, the probability of not A and not B is equal to 0.4, and the probability of not A and B is equal to 0.2. Then the probability of not A union B complement is. Okay, so the first thing that I did with this event was that I wrote my probabilities. So the probability of A is equal to 0.7. The probability of not A union not B is 0.4. Yes, which is what I'm given right on the second probability. This will translate to, remember Morgan's rule. Morgan's rule. This will translate to this. It will translate to the probability of A and B intersection, right? I mean complement. So in order to find, remember when I have P of A, I can always find P of complement A. So when I have complement of A, I can find A. Same as this. In this instance, I have the complement, so I can find the original one by saying 1 minus that. So the probability of A and B is going to be equal to 0.6. I'm also given that the probability of not A intersection B is equal to 0.2, right? If you find the complement of these, of what this is, right? So if you find the complement of this, you're going to say the probability of whatever this is complement, right? And this is going to be equal to 1 minus 0.2, and I get 0.8. This is going to translate to, this is going to translate to this. The probability of not A and not B. I mean union, because I'm separating the big brackets. I'm so sorry about that. Separating the big brackets, right? Okay, cool. So, yep. Okay, so from all these things that I just wrote, it was just a matter of using your complement rule. I hope you can still see. It was just a matter of using your complement rule to write them down. After you have done that, you will now write the probability of A, which is 0.7. The probability of not A is 1 minus the probability of A, which is 0.3 in this instance, which will all equal to 1. And then remember, I found the probability of A and B from this. What did I do? I found the complement of this. So when I find the complement of this, I need to swap it around, right? Or you can use Morgan's rule. So whenever you have these two things, let me show you Morgan's rule actually, because I feel like some of you might get confused with what I'm doing. I'm not really teaching the content. I'm just like applying the content. So I'm guessing you've watched some of my videos. So we are looking at the union one. So it's this. The probability of not A union not B is equal to the probability of A and B complement. So that's exactly what I did here, right? And after I did this, I found the complement of this, right? So I found this is equal to the probability of A union B complement, which gives me the original one, probability of A and B, which is equal to 0.6, right? Okay, so now that I found 0.6, I put it into my formula, into my table. This is what they asked me for. But in order to solve for this, I need to say 0.7 minus 0.6, which gives me 0.1, which is what they asked me for. So, but before we get there, what they asked me for was the probability of not A union B. So what I would first do is to separate this, right? So how do I separate it? I first turn this sign upside down, and then I write what I had, probability of A, not A, right? Intersection, probability of, okay, probability of B, and then I put those separated signs. So I'm gonna have the probability of not A and the probability of not B. So not A, when it has two things, it gives us the original one. So in this instance, it's not A, which is the probability of A, and the probability of not B, right? So to find that, it's here, the probability of, okay, so obviously you have to put this here, right? And then find this using the complement rule as well as the Morgan's rule, and then solve for this, right, which is 0.1. So if you guys don't understand, yeah, if you don't understand, okay, I'm uploading this video on YouTube, but I did explain this in the group chat that I have, and it was one of the questions that was asked. But in the group chats, I actually used a different method. I used the intersection rule as well as the addition rule to solve this question. So if this is complicated to you and you're studying advanced and you're in the group chats, please make sure you go to the group chats. Someone asked the question. It's question 9, so you can just look over my workings to try and understand it better. And if you're not studying advanced and you still don't understand, please comment in the section below, and I'll try to explain it in the way that I explained it in the group, because it seems to make sense in that method. Okay, so yeah, or you can try to replay the video or this parts of the video. Last question. Okay, so the answer would be A, 0.1. Number 10, the probability, oh, I need to go to the question, sorry. Please make sure you aim for 100 in this test. As I said in the previous video, that we aim for the highest mark possible, and the highest mark possible is 100. So that when you fall, if you do fall, you fall to your 90s, 80s, and 75s, right? So the last question, I'm so tired, guys. I'm so sorry for my sleepy voice. The last question says, a company sells 60% of its wristwatches with cameras, right? So C, and 45% of its wristwatches with Bluetooth. So with Bluetooth, if 35% of the wristwatches have both cameras and Bluetooth, find the probability that the watch has neither. So find the probability that the watch has neither a camera and no Bluetooth. So that's what I'm looking for, right? So what am I going to do first? I'm going to write my probabilities. They told me that the probability of C is equal to 60%. The probability of B is equal to 45%. And the probability of C and B is equal to 35%. So they are asking for not B and not C. B being the Bluetooth and C being the camera, right? So what am I going to do to answer this question? Draw my contingency table, right? So what is the probability of C? I write it down, 60%. Probability of not C, it's 1 minus C, which is 1 minus 60%, which gives me the 40%. Add these two, I get 100%. Probability is always equal to 1, or it is always equal to 100%. And then the probability of B, I write it down, is 45%. The probability, and then I solve, because I have this and I have this now, so I solve for this, right? And then they told me that the probability of C and B, so the probability of C and B, 35%, right? Now I have this and I have this, so I solve for this, right? Okay, I've solved for 25%. Now I have this and I have this, so I solve for the 20%. I have this and this, so I solve for the 10%, right? And then you answer the question. What did the question ask for? It asked for the intersection of not B and not C. Not B, not C, 30%. So the answer is B, 0.30. If you don't know how to do a contingency table, please watch my video on the tips you should know before test 2, because I explained how to do the contingency table, explained how to do the tree diagram, I explained how to use notation, I explained the Morgan's rule, intersection rule, and addition rule. So make sure you don't get into that exam room without watching the video, right? So this brings me to the end of the test 2 set D. So thank you so much for watching. Please don't forget to comment, like, and subscribe, and please, most importantly, don't forget to subscribe, right? So please share the video so that it helps somebody else. Even if you're studying at Wits and you know a person who's studying at UJ, studying at UCT, studying at UKZN, University of Western Cape, University of Free State, wherever they're studying and they are doing stats will always be the same. Maths is maths at the end of the day. Do share the video to them so it helps them as well. So thank you so much for watching. Bye guys.